Trigonometric ratios of quadrantal angles. Let us see what are quadrantal angles. Angles which are the integral multiples of pi by 2 are called quadrantal angles, or integral multiples of 90 degrees, where n belongs to z, the set of all integers 0, plus or minus 1, plus or minus 2, etc. For example, 0 radians, plus or minus pi by 2 radians, plus or minus pi radians, plus or minus 3 pi by 2, plus or minus 2 pi, etc. are quadrantal angles. In terms of degrees, the quadrantal angles are 0 degrees, plus or minus 90 degrees, plus or minus 180 degrees, plus or minus 270 degrees, plus or minus 360 degrees, etc. are called quadrantal angles. We know the trigonometric ratios for certain acute angles like 30 degrees, 45 degrees, 60 degrees. We have learned them in lower classes. Now, let us learn the trigonometric ratios of these quadrantal angles. Let us consider this unit circle. Unit circle means with radius 1 unit. We are considering a circle with radius 1 unit to make our calculations easier. The quadrantal angles are marked here: 0 degrees, 90 degrees, 180 degrees, 270 degrees, 360 degrees, etc. Consider a point P on this unit circle. Let us join the origin and this point P and draw a perpendicular PM perpendicular to the x-axis. Let this angle be theta. In triangle OPM, cos theta will be adjacent side by the hypotenuse. Here the hypotenuse is 1 unit, which is the radius of the circle, from which we can get the value for OM. OM is cos theta. And in the same triangle, sin theta is opposite side PM by the hypotenuse. Therefore, PM is sin theta. Let me write these things in the figure. OM length is cos theta value and PM length is sin theta value. So, the coordinates of P can be written as cos theta sin theta. So, P point is, x coordinate is cos theta and y coordinate is sin theta. In the first quadrant, we know that both x and y coordinates are positive. Therefore, cos theta and sin theta values are positive when theta is in the first quadrant, that is between 0 degrees and 90 degrees. If P point is in the second quadrant, theta is an obtuse angle, PM is the perpendicular drawn, and angle alpha will be the reference angle of theta. Reference angle is an angle made with the terminal side of the angle with the x-axis which is closer to it. If P is in the second quadrant, the x coordinate of P point will be negative and y coordinate of P point will be positive. Therefore, if theta is in the second quadrant, cos theta value will be negative and sin theta value will be positive. If P point is in the third quadrant, this is theta and the reference angle is alpha. In the third quadrant, both x and y coordinates are negative. Therefore, cos theta and sin theta values will be negative when theta is in the third quadrant. And if P point moves to the fourth quadrant, say, theta will be a fourth quadrant angle which is between 270 degrees and 360 degrees. Alpha is the reference angle of theta. Since P is in the fourth quadrant, the x coordinate is positive and y coordinate is negative. So, for a fourth quadrant angle theta, cos theta will be positive and sin theta value will be negative. In this unit circle, this P point can be anywhere on this unit circle. As we move P point, the adjacent side and the opposite sides are changing. That means cos theta and sin theta values are changing. Now, if P comes and coincides with this point M, say, the coordinates of P point are 1, 0, theta becomes 0 in this case. Therefore, cos 0 value becomes 1 and sin 0 value becomes 0. In this case, the triangle becomes a straight line. We have only the adjacent side which becomes 1 and the opposite side becomes 0. That is how sin 0 is 0 and cos 0 value is 1. Now, in the first quadrant, as P moves along the unit circle, sin theta value increases, the opposite side increases, and the adjacent side decreases. So, cos theta decreases in the first quadrant. And when theta becomes 90 degrees, the adjacent side cos theta becomes 0, therefore, cos 90 is 0 and sin 90 becomes 1. If theta is in the second quadrant, look at P coordinates. X coordinate becomes negative, y coordinate becomes positive. That means cos theta value will be negative and sin theta value will be positive. Alpha is the reference angle of theta. As theta increases, cos value decreases, sin value is also decreasing. And if theta becomes 180 degrees, look at the coordinates of P, minus 1 and 0. Therefore, cos 180 degrees will be minus 1 and sin 180 degrees is 0. If theta becomes a third quadrant angle, that is more than 180 degrees, look at the coordinates of P. Both the coordinates are negative. Therefore, cos theta value will be negative, sin theta value also will be negative for a third quadrant angle. Alpha is the reference angle of theta. And when theta becomes 270 degrees, look at the coordinates of P. P becomes 0, minus 1. Therefore, cos theta value becomes 0, that is cos 270 degrees is 0, sin 270 degrees is minus 1. As theta increases, it goes to the fourth quadrant. Look at the coordinates of P. In the fourth quadrant, x coordinate is positive, y coordinate is negative. So, for a fourth quadrant angle, cos theta value will be positive and sin theta value will be negative. Alpha is the reference angle of theta, and as theta increases and if it becomes 360 degrees, look at the coordinates of P point, it has become 1, 0. Therefore, cos 360 degrees is 1 and sin 360 degrees is 0, which are the same values as 0 degrees. We have to be thorough with these values. We already know the values for pi by 6, pi by 4 and pi by 3, and now we have learnt the trigonometric ratios for quadrantal angles also. And we know that tan theta is sin theta over cos theta. So, by dividing these values we get tan theta value. If the denominator is 0, tan theta will be not defined. We can find cosecant theta value, which is the reciprocal of sin theta, and secant theta, which is the reciprocal of cos theta, and cot theta value is cos theta upon sin theta. Now, let us see the sign of trigonometric functions in each quadrant. If we know the signs for cos theta and sin theta, easily we can decide the signs for the other trigonometric ratios, because tan is sin over cos and cosec is reciprocal of sin, secant x is reciprocal of cos and cot is reciprocal of tan. We can remember these signs easily by the mnemonic A, S, T, C. All silver tea cups, or after school to cinema, or all students take calculus. A, S, T and C. A stands for all. All trigonometric ratios are positive. See, in the first quadrant all trigonometric ratios are positive. In the second quadrant, S stands for sine and its reciprocal cosecant. In the second quadrant, only sine and cosecant are positive. All other trigonometric ratios are negative. In the third quadrant, T stands for tan and its reciprocal cot. So, in the third quadrant, tan x is positive, cot x is positive. Other four trigonometric ratios are negative. And in the fourth quadrant, C stands for cos and its reciprocal secant. See the fourth quadrant, only cos x and secant x are positive, other trigonometric ratios are negative. Now, let us see the relationship for some key angles like 30 degrees, 45 degrees, 60 degrees using unit circle. This is 30 degrees, 150 degrees, 210 degrees and 330 degrees. For 150 degrees, the reference angle is 30. This angle is 210 degrees and its reference angle is 30 degrees. Reference angle is the angle which the terminal side of the angle makes with the nearer x-axis. And this angle is 330 degrees and its reference angle is 30 degrees. P, P dash, P double dash, P triple dash. All these 4 points are reflections of each other on x and y axes. And these 4 right triangles are congruent. And we know that every point on this unit circle gives cos theta, sin theta values. And we know that in the first quadrant, both x and y coordinates are positive. In the second quadrant, x is negative, y is positive. In the third quadrant, both are negative. And in the fourth quadrant, x is positive, y is negative. Now, for 30 degrees, cos 30 degrees is root 3 over 2 and sin 30 degrees is half. As it is in the first quadrant, both are positive. And in the second quadrant, cos 150 degrees is negative root 3 over 2 and sin 150 degrees is half. And in the third quadrant, cos 210 degrees is negative root 3 over 2 and sin 210 degrees is negative half. And in the fourth quadrant, cos 330 degrees is root 3 over 2 and sin 330 degrees is negative half. So, for all these 4 angles, the values are same, only sign difference will be there according to the quadrant in which the angle lies. And if we know cos theta and sin theta values, we can calculate all other trigonometric functions. Next, let us consider 45 degrees. This is 45 degrees, this is 135 degrees, and this is 225 degrees, and this is 315 degrees. All their reference angles are same. This is 45 degrees. For 135 degrees, 45 degrees is the reference angle, and for 225 degrees, the reference angle is 45, and for 315 degrees also the reference angle is 45 degrees. Look at cos theta and sin theta values for these 4 angles. The values are same, only sign difference will be there according to the quadrant in which the angle lies. Cos 45 degrees is 1 upon root 2 and sin 45 degrees is also 1 upon root 2. Both are positive. And the second quadrant angle 135 degrees, cos 135 degrees is negative 1 upon root 2 and sin 135 degrees is positive 1 upon root 2. And cos 225 degrees is negative 1 upon root 2 and sin 225 degrees is negative 1 upon root 2. And cos 315 degrees is 1 upon root 2 and sin 315 degrees is negative 1 upon root 2. Now, let us do for 60 degrees. This is 60 degrees, 120 degrees, 240 degrees and 300 degrees. For all these 4 angles, the reference angle is the same. Now, cos 60 degrees is positive half and sin 60 degrees is root 3 over 2. And cos 120 degrees is negative half and sin 120 degrees is root 3 over 2. And cos 240 degrees is negative half and sin 240 degrees is negative root 3 over 2. And cos 300 degrees is half and sin 300 degrees is negative root 3 over 2. Already we have seen cos and sin values for the quadrantal angles. Now, let us see how the sine curve is. Consider a unit circle. OP is the radius, so it will be 1 unit. Let angle POM be theta. From the right triangle OPM, sin theta will be opposite side by the hypotenuse. Hypotenuse is 1, so PM is equal to sin theta. and we know that the point P is cos theta comma sin theta. As P moves on the circle, theta also changes. If P coincides with M, theta will be 0 degrees. So sin theta is 0 here. As theta increases in the first quadrant, sin theta value increases. Look at that line segment PM. It increases. And when theta is equal to 90 degrees, sin theta takes the maximum value 1. So sin theta value increases from 0 to 1 in the first quadrant. And in the second quadrant, sin theta decreases. Look at the red line. It decreases and it becomes 0 when theta is equal to 180. Therefore, in the second quadrant, sin theta decreases from 1 to 0. And we know that in the first quadrant, all trigonometric ratios are positive. And in the second quadrant, sine and cosec are positive. And in the third quadrant, tan and cot are positive. Other trigonometric ratios will be negative. And in the fourth quadrant, cos and secant are positive. Other trigonometric ratios are negative. ASTC rule. So in both the first and the second quadrant, sin theta will be positive. And in the third quadrant, sin theta value is going to be negative because y coordinate will be negative here. Look at PM. So it decreases because it is a negative value. So it becomes minus 1. The least value which sin theta takes is minus 1. And in the third quadrant, sin theta value decreases from 0 to minus 1. And in the fourth quadrant, again sin theta is negative. So as P moves, PM increases from minus 1 to 0. Therefore, in the fourth quadrant, sin theta value increases from minus 1 to 0. From this unit circle, we can make out that the maximum value of sin theta is positive 1 and the minimum value of sin theta is negative 1. And theta can take any value. We can go for the second revolution also. And similarly, we can move in the negative direction. Therefore, theta can take any value, but sin theta takes values from negative 1 to positive 1. The domain of the function is the set of all values which theta can take. Here theta can take any real value, and range is set of all values which sin theta can take. So we know that sin theta takes values between minus 1 and plus 1, including minus 1 and plus 1. Now let us draw the graph of sine function. So let us take theta along x-axis. I have taken in radians, and sin theta values along y-axis. When theta is 0, sin theta is 0. 0, 0 is a point on the graph. And in the first quadrant, sin theta value increases as theta increases. And when theta is pi by 2, that is 90 degrees, sin theta is 1. And then in the second quadrant, it decreases. When theta is 180 degrees, that is when theta is pi radians, sin theta value is 0 again. And when theta is 270 degrees, sin theta value is minus 1. That is for 3 pi by 2, sin theta is minus 1. And for 2 pi, sin theta is again 0. Let us join these points with a freehand curve. So this is the sine curve for the period of 2 pi. So the same curve repeats from 2 pi to 4 pi. Same way we can extend the graph in the negative direction too. From the sine curve also we can make out that sin theta's maximum value is positive 1 and the minimum value is negative 1. And theta can take any real value on x-axis. That's why domain is R and the range is closed interval negative 1 to positive 1. Now let us draw the cosine curve. Consider this unit circle whose radius is 1 unit. Look at the triangle OPM. In that right triangle, cos theta value will be adjacent side upon hypotenuse. Hypotenuse is 1 unit. The x coordinate of P point represents cos theta value. If P point coincides with this M point, theta will be 0. Cos theta value becomes 1. The length of the pink line is cos theta value. If we follow ASTC rule, cos theta value will be positive in the first quadrant and cos theta value will be negative in the second and the third quadrants, because the x coordinate will be negative in both these quadrants. And in the fourth quadrant, again x coordinate, cos theta value will be positive. As theta increases in the first quadrant, cos theta value decreases. Look at the length of the pink line. It reduces as theta increases. In the first quadrant, cos theta decreases from 1 to 0. Here theta is 90 degrees, cos theta is 0. There is no pink line. The x coordinate of this P point will be 0. And in the second quadrant, for obtuse angle, cos theta value will be negative, because x coordinate is going to be negative in the second and the third quadrants. As theta goes in the second quadrant, look at the pink line. It becomes negative, so it decreases from 0 to minus 1. When theta is 180 degrees, cos theta value becomes minus 1. In the third quadrant, as theta increases, cos theta also increases from minus 1 to 0, but it will be negative in the third quadrant. And cos 270 degrees is 0, because P point's x coordinate is 0. And then if theta is in the fourth quadrant, cos theta value increases. Look at the length of the pink line. It is increasing. So, in the fourth quadrant, cos theta increases from 0 to 1. When theta is 360 degrees, cos theta value is 1. So, the maximum x coordinate of P point is positive 1 and the minimum x coordinate of P point is negative 1. So, the domain of the function, the set of all values for theta is R, because we do not have not defined case for any real value of theta, and we know that cos theta's maximum value is positive 1 and minimum value is negative 1. This is the range of the cosine function. Let us plot the points and draw the graph of cos function. Let us take theta along x axis and cos theta values along y axis. And here theta values are in radians. For theta equal to 0 degrees, cos theta value is 1. And if theta is 90 degrees, cos theta value is 0. And if theta is 180 degrees, that is pi radians, cos theta value is negative 1. And for 270 degrees, cos theta is 0. And for 360 degrees, cos theta value is positive 1. Let us join these points by a smooth curve. This is the cos curve for the period of 2 pi. So, same curve can be repeated for 2 pi to 4 pi. Same way we can continue the graph in the negative side of x axis also. Cosine curve is also a wave like curve. Domain of the cos function is R, the real number set, and the range is closed interval minus 1 to 1. From the graph of the cosine curve also we can make out that the maximum value of cos function is positive 1 and the minimum value of cos function is negative 1. Now we will see the graph of tan theta. Consider the unit circle, OM is the radius, which is 1 unit. In triangle OMN, tan theta value is opposite side, which is MN, upon the adjacent side OM, which is the radius. Radius is 1 unit, so we get MN. When theta is 0, tan theta value is 0. As theta increases in the first quadrant, look at the line segment MN. It is increasing. Therefore, tan theta value increases from 0 to infinity. Very big it becomes as theta approaches 90. And when theta is 90 degrees, tan theta is not defined. And when it is little more than 90, it comes to the second quadrant. In the second quadrant, tan theta will be negative. And look at the length of MN. As theta increases in the second quadrant, tan theta increases from minus infinity to 0. So, tan 180 degrees is 0, and in the third quadrant, as theta increases, tan theta value increases. Look at the line segment MN. So, as theta increases in the third quadrant, tan theta value increases from 0 to infinity. So, tan 270 degrees is not defined. And in the fourth quadrant, as theta increases, tan theta increases from minus infinity to 0. Tan 360 degrees is 0. Now, from this figure we can make out that tan theta is not defined when theta is plus or minus pi by 2, plus or minus 3 pi by 2, plus or minus 5 pi by 2, etc. So, at all odd multiples of pi by 2, tan theta is not defined. Therefore, the domain of this function is all real values of theta except odd multiples of pi by 2, where n belongs to z, set of all integers. And range for tan function is, it goes up to plus infinity as well as minus infinity. So, it can take any real value. This is the range of tan function. Now, let us plot the points and draw tan curve. When theta is odd multiples of pi by 2, tan theta is not defined. Therefore, at those values the dotted lines have been drawn. We do not have tan theta values for those angles. And we have taken theta along x axis and tan theta along y axis. At pi by 2, tan pi by 2 is not defined. And in the second quadrant, if it is little more than pi by 2, tan theta value will be very large but negative, and tan pi value is 0. And this is the graph of tan function for the period of pi. Again, in the third quadrant, it increases from 0 to infinity. When theta is 3 pi by 2, tan theta is not defined. This is the graph of tan function. Now, let us see about cosecant theta function and its graph. See the angle theta. Angle OAP is also equal to theta. Now, from the right triangle OAP, we will find cosecant theta. Cosecant theta is hypotenuse upon the opposite side. Opposite side is the radius, which is 1 unit, because we have taken a unit circle. Therefore, OA represents cosecant theta value. And we know that cosecant theta is 1 upon sin theta. Denominator should not become 0. Wherever sin theta becomes 0, cosecant theta is not defined. So, sin theta takes the value 0 at all multiples of pi, where n belongs to z. Therefore, the domain of the function cosecant theta is r minus n pi. Let us see the values of cosecant theta in the first quadrant. As the point P moves, if theta is 0, cosecant theta is not defined, because 1 upon 0 not defined, it does not have a value. If theta is little more than 0, cosecant theta will be a very big positive quantity, which we denote it as positive infinity. If it is little less than 0, fourth quadrant angle, cosecant theta will be a very big negative quantity, which we denote it as negative infinity. As theta increases in the first quadrant, look at the value of cosecant theta. That OA line segment gives cosecant theta value. It decreases as theta increases in the first quadrant, cosecant theta value decreases, OA length decreases. And let us see what happens when it becomes 90 degrees. If theta becomes 90 degrees, cosecant theta value is 1. This is the minimum positive value which cosecant theta takes. Or in the first quadrant, I can say that cosecant theta decreases from infinity to 1. In the second quadrant, we know that cosecant theta values are positive. So, as theta increases in the second quadrant, cosecant theta value also increases. Look at the line segment OA. Here the reference angle and angle OAP will be the same. And in the second quadrant, cosecant theta increases from 1 to infinity. And when theta is 180 degrees, cosecant theta is not defined. If theta is little less than 180 degrees, cosecant theta will be a very big positive quantity, which is positive infinity. And if it is little more than 180 degrees, cosecant theta will be a very big negative quantity, which we denote it as negative infinity. And in the third quadrant, as theta increases, cosecant theta values are negative. It increases from minus infinity to minus 1. So, cosecant 270 degrees value is minus 1. And then in the fourth quadrant, as theta increases, cosecant theta decreases from minus 1 to minus infinity. Cosecant theta becomes minus infinity as theta increases. And when theta becomes 360 degrees, cosecant theta is not defined. Therefore, the range of cosecant theta function is r minus open interval minus 1 to 1. We know that sin theta function takes all real values between negative 1 and positive 1, and cosecant theta is the reciprocal of this. Therefore, it takes values from 1 to infinity and minus infinity to minus 1. Therefore, the range is r minus negative 1 to 1 open interval. Now, we will see the graph of cosecant theta function. Look at the black vertical lines. At all those integral multiples of pi, cosecant function is not defined, and it does not take values between negative 1 to 1. Now, we will see secant function and its graph. Let us consider this unit circle. In triangle OAP, secant theta is hypotenuse, which is OA, upon the adjacent side, which is the radius 1 unit. Therefore, OA gives secant theta value, and secant theta is 1 upon cos theta. Wherever cos theta is 0, secant theta is not defined, and we know that cos theta becomes 0 for all odd multiples of pi by 2, where n belongs to z. Therefore, the domain for secant function is r minus all odd multiples of pi over 2, where n belongs to z. So, secant theta is not defined at these values. For all other real values, secant theta is defined. And we know that minus 1 less than or equal to cos theta less than or equal to 1. Cos theta takes all real values from negative 1 to positive 1. Secant theta is the reciprocal of cos theta. It takes values from 1 to infinity and minus infinity to minus 1. Therefore, the range for secant function is r minus open interval negative 1 to positive 1. As p point moves, if theta becomes 0, secant theta is 1. And in the first quadrant, secant theta is positive. OA is the secant theta value. As theta increases in the first quadrant, secant theta increases from 1 to infinity. For an angle which is less than 90, secant theta is a very big answer. So, we denote it as infinity, and for 90 degrees, secant theta is not defined. For little less than 90, it takes a very big positive value, and for little more than 90, it takes a very big negative value. So, we denote it as negative infinity. Therefore, in the second quadrant, As theta increases, secant theta increases from negative infinity to negative 1. So, secant 180 degrees is negative 1. In the third quadrant, secant theta is negative and it decreases from negative 1 to negative infinity. Look at OA, it approaches negative infinity. Positive infinity and negative infinity are just symbols denoting that they are very large quantities. And if theta is 270 degrees, secant theta is not defined because cos 270 degrees is 0. For little less than 270 degrees, secant theta is a very big negative value, so negative infinity. For little more than 270 degrees, secant theta is positive, so we denote it as infinity. And as theta increases, secant theta decreases in the fourth quadrant, decreases from infinity to 1, and secant 360 degrees is 1. See the graph of secant theta function? The secant function is not defined for all odd multiples of pi by 2, and it does not take values between negative 1 to 1. Let us now see about cot theta function and its graph. Angle OAP is also theta. Therefore, in triangle OAP, cot theta is adjacent side upon opposite side. Adjacent side of angle OAP is AP and the opposite side is the radius, which is 1 unit. Therefore, AP gives cot theta value. And we know that cot theta is cos theta upon sin theta. Whenever sin theta is 0, cot theta is not defined, and sin theta becomes 0 for all integral multiples of pi. Therefore, the domain of the function cot theta is r minus all integral multiples of pi. Now, range for cot function is the real number set. It can take any real value. In the first quadrant, all trigonometric ratios are positive, so cot theta is also positive. Now, the purple line AP gives cot theta value. As theta decreases in the first quadrant, cot theta increases and cot 0 is not defined. And if it is little more than 0, its value is a very large positive quantity, and if it is little less than 0, it is a very large negative quantity. And as theta increases in the first quadrant, cot theta decreases from infinity to 0. So, cot 90 degrees or cot pi by 2 radians is 0. In the second quadrant, cot theta is negative, and look at AP line segment. It decreases from 0 to minus infinity. As theta increases in the second quadrant, cot theta decreases from 0 to negative infinity. And cot 180 degrees or cot pi radians is not defined. For little less than 180 degrees, it is negative infinity, and for little more than 180 degrees, it is positive infinity, because cot theta is positive in the third quadrant. And as theta increases in the third quadrant, cot theta decreases from infinity to 0. Cot 270 degrees is 0, and in the fourth quadrant, cot theta will be negative because sin theta is negative in the fourth quadrant. And as theta increases in the fourth quadrant, cot theta decreases from 0 to negative infinity. So, cot 2 pi radian is not defined. Now, let us see the graph of cot function. At all integral multiples of pi, cot theta is not defined. those are the dotted black lines, and cot theta can take any real value, therefore the range is R. Like tan theta, cot theta value also repeats after an interval of pi. Let us do exercise 3.2. Find the values of other 5 trigonometric functions in exercises 1 to 5. To do these questions, we may use the identities or we may use the triangle method. I am going to use the triangle method. Question number 1. Cos x is given as negative half, where x lies in the third quadrant. We know ASTC rule, and in the third quadrant only tan and its reciprocal cot are positive. All other trigonometric ratios are negative. Let us draw a right triangle. X is in the third quadrant. We are drawing the triangle with a reference angle of x. So, when you write the sides, you need not consider the negative sign. Cos is adjacent side divided by the hypotenuse. So, we will calculate the opposite side, which is under root 2 square minus 1 square using Pythagoras theorem. We get root 3. Now, we will be able to write the other 5 trigonometric ratios. Sin x. Sin x in the third quadrant is negative, and sin is opposite side upon the hypotenuse. Cos x is already given in the question. Now, tan x. Tan x is sin x over cos x, or tan x in the third quadrant is positive and tan is opposite side divided by the adjacent side. The answer is root of 3. Cosecant x is the reciprocal of sine function. So, negative 2 upon root 3. Secant is reciprocal of cos function, negative 2, and cot x is reciprocal of tan function, which is 1 upon root 3. Second question, sin x is 3 over 5. X lies in the second quadrant. In the second quadrant, using ASTC rule, only sine and its reciprocal cosecant are positive. All other trigonometric ratios are negative. Let us draw a right triangle. X is in the second quadrant. So, we have drawn a right triangle with a reference angle of x. Sine is opposite by the hypotenuse. We can find the adjacent side, which is 5 square minus 3 square root 16, and it is 4. Now, we will write the other 5 trigonometric ratios. In the second quadrant, cos is negative and it is adjacent by the hypotenuse, and tan x is in the second quadrant, tan is negative and it is opposite by the adjacent. Cosecant x is reciprocal of sine, which is 5 over 3, and secant x is reciprocal of cos, which is negative 5 over 4, and cot x is reciprocal of tan x, which is negative 4 over 3. Question 3. Cot x is 3 upon 4 and x lies in the third quadrant. We know that in the third quadrant, only tan and its reciprocal cot are positive, other 4 trigonometric ratios will be negative. Here x is a third quadrant angle. We are drawing a right triangle which is in the third quadrant. Cot is adjacent side by the opposite side. We will calculate the hypotenuse using Pythagoras theorem. It is 16 plus 9 under root 25, which is 5. Now, we will write the other 5 trigonometric ratios. Sin x in the third quadrant, don't forget about the quadrant, accordingly we have to put the sign. In the third quadrant, sin is negative and it is opposite side by the hypotenuse, and cos x is negative and it is adjacent by the hypotenuse. Tan x is reciprocal of cot function. Cot value is given already, so its reciprocal is 4 upon 3, and cosecant x is reciprocal of sin x, negative 5 over 4, and secant x is reciprocal of cos x negative 5 over 3. Fourth question, secant x is 13 over 5 and x lies in the fourth quadrant. In the fourth quadrant, cos and its reciprocal secant are positive, other trigonometric ratios are negative. So, it is in the fourth quadrant and we have drawn this right triangle. Secant is hypotenuse upon the adjacent, we will find the opposite side. Root of 13 square is 169 minus 5 square is 25. We get under root 144, which is 12. We will write the other 5 trigonometric ratios. Sin x is negative in the fourth quadrant. So, negative 12 over 13, opposite side by hypotenuse, and cos x is positive and it is adjacent by the hypotenuse, and tan x is sin divided by cos, or tan is negative in the fourth quadrant and it is opposite side upon the adjacent side, and cosecant x is reciprocal of sine function, which is negative 13 over 12, and secant x is given. Cot x is reciprocal of tan, which is negative 5 over 12. Fifth question, tan x is negative 5 over 12 and x lies in the second quadrant. In the second quadrant, sine and its reciprocal cosecant are positive, other 4 trigonometric ratios are negative. X is a second quadrant angle. So, with the reference angle we have drawn this right triangle. No need to consider the minus sign when you use the triangle. When we write the trigonometric ratios, we will consider the sign according to the quadrant which is given. Tan is opposite by adjacent. So, let us calculate the hypotenuse, which is 5 square plus 12 square, which is 144, 1 under root 169, which is 13. Now, we will write the other trigonometric ratios. Sin x in the second quadrant is positive and sin is opposite side upon the hypotenuse, and cos x in the second quadrant is negative. Be careful about the sign, do not forget to put the signs. Cos x is adjacent side by the hypotenuse, 12 over 13. Tan x is given in the question, and cosecant x is reciprocal of sine function, which is 13 over 5, and secant x is reciprocal of cos function, negative 13 over 12, and cot x is reciprocal of tan function, which is given. So, it is negative 12 over 5. Question 6. Find the values of the trigonometric functions in exercises 6 to 10. Sixth question, we have to find sine 765 degrees. Now, sine 765 degrees can be written as sine of 720 degrees plus 45 degrees. 720 makes 2 complete revolutions, 360 times 2. 45 degrees, 765 degrees. One revolution is 360, second revolution is 720 and plus 45. It takes up the same position as 45 degrees. So, all trigonometric ratios for these two angles are going to be the same. This will be equal to sine 45 degrees, and sine 45 degrees is 1 upon root 2. Question 7. Cosecant negative 1410 degrees. Cosecant negative 1410 degrees plus 1440 degrees. 1440 degrees is 4 complete revolutions. If we add or subtract any number of complete revolutions, the trigonometric ratio does not change. or this may be written as cosecant negative 1440 degrees plus 30 degrees, because this difference will be negative 1410 degrees, and this is 4 complete revolutions but in the negative direction. So, this will be equal to cosecant 30. We may do like this also. And this becomes 30 degrees. 30 degrees is in the first quadrant, and negative 1410 degrees in the negative direction, one revolution, which is negative 360, negative 720, negative 1080 degrees, 3 revolutions, and the fourth one, here it comes. If you complete the whole revolution, it will be negative 1440. We are not completing it, we are stopping it here. So, this is negative 1410 degrees. So, negative 1410 degrees and positive 30 degrees, they take the same positions. So, cosecant of these two angles will be the same, and cosecant 30 degrees is 2. Eighth question, tan 19 pi over 3. 19 divided by 3, 3 goes 6 times. So, we can write this as tan of 6 pi plus pi over 3. Take LCM and see. 18 pi plus 1 pi is 19 pi over 3, and 6 pi is 3 complete revolutions. Pi by 3 is in the first quadrant, and 19 pi over 3, 1 revolution, second, third. So, this is 19 pi over 3. They take the same positions. This will be tan pi by 3. If we add or subtract any number of complete revolutions to an angle, the value of the trigonometric function does not change. And tan pi over 3 is root 3. Ninth question, sine of negative 11 pi over 3. If the angle is negative, we will add the complete number of revolutions. So, the closer number 12 by 3, which is 4. So, I am adding 4 pi. 4 pi is 2 complete revolutions. 2 pi is 360 degrees, 1 revolution. So, 4 pi is 2 complete revolutions. So, by adding any number of complete revolutions, the value of the trigonometric function does not change. Sine of, by taking LCM 3, we get negative 11 pi plus 12 pi. It is sine pi over 3. The value is root 3 upon 2. 10th question, cot of negative 15 pi over 4. So, the closer number is 16 over 4, which is 4. So, we will add 2 complete revolutions to this given angle, which is 4 pi. 16 by 4 is 4. 4 pi is 2 complete revolutions. Let us take LCM. Negative 15 pi plus 16 pi, and it becomes cot of pi over 4. Cot pi over 4 is 1.